Good day to you all. This is certificate code P4, conducting a renewable energy project, technical and financial feasibility study. This topic is on Introduction to Project Feasibility Studies. Under that main topic, there will be three subtopics: project planning, project feasibility study, and risk associated with the projects. So now let's learn about the subtopic project planning. I am Gani Ratnasekara. Here is the presentation outline where you will learn about project planning cycle. There are 7 key areas of project planning cycle where you will be learning about project acquisition, planning, approval stage, realization stage, financing models, implementation, operation and maintenance, the final stage. Now let's move on to the first stage, project or site acquisition. There are several steps related to this project site acquisition that you will learn on. So the step 1 is determine the site, scale, resource, and community market potential. Because acquisition is very important stage and that's why it is line on very first. In that step, determination of this site, its scale, its resources, its community is very important. So that comes to step number 1. So what are the tasks related to that? Identify possible sites for project locations is very important. It depends on solar, wind, and all other renewable energy sources according to its availability and all. So let's see. Then determine the energy load or demand for these sites using past electric bills for these facilities. Then we want to confirm the renewable energy resource that we are going to use in that according to the project location. Then we have to review the tribal facility electric cost data, regulations, and transmission and interconnection requirements. Then we have to evaluate community market potential for renewable sales. Your community is the marketplace or the energy user. And finally, we have to assemble or communicate with the right team, those in positions or with knowledge to facilitate, approve, and champion this project. That is very important for the success of the project. And the next step, step number 2, is scale the renewable energy system. So how can we do that? First step is from current load analysis. So we can use past monthly energy bills to determine its demand. So we can have a rough sketch of the demand, how it has happened, and we can forecast. Then we can consider the scale, whether that is a residential one, a commercial one, or industrial one accordingly. And then we can consider the current tariff structure, how the energy is metered and billed. And then we can go for future load. How we can do? We can identify the future energy demand of the surrounding communities. And then we can identify other limiting factors like its interconnection, net metering caps, rebate limits, likewise. And step number 3, that is to assess on resource availability, because that is more important when we are considering our renewable energy required for this energy generation in the specified area. So first we have to assess the available local energy resources. For that, we can identify and analyze the production of available energy resources using several techniques. So what can we use? We can use online tools, then field-based measuring equipment, resource maps. Likewise, we can use. So you can see some examples shown here that NREL, they have plotted the photovoltaic solar resources of United States, the annual average wind speed, So we can determine according to the location whether this will be applicable for this project location. Likewise, we can plot on the and assess the available local energy resources. And then we can identify siting obstructions if we have any obstructions for this continuation of the project. So we can categorize the obstructions according to local energy sources. So below is an example for that. So if we are moving for a wind power plant, then we want to look on whether there are obstructions from tall buildings, trees, forestry area, likewise. Because if there are such obstacles for the project, then applicability of that renewable energy source for this project will be inefficient. So we want to look on that. And then next one is identify where to install the plant. That is a very important and keen thing because we want to have continuous flow of energy without any disturbance. Therefore, location and installation is very important. So clear illustration is provided with an example to install solar plant is given below. So you can see on the built environment or on top of existing buildings, we can have this solar power plant. So for that, we can use existing building roofs that have an expected life of at least 15 years or more and can accept added load, typically the solar panel and the accessories extra weight. Because if the building is not capable of holding the solar panel and its relevant accessories, then it will become a huge risk in the future for the durability of both the building and the solar panels and other related devices. And then all new buildings where solar panels can be fixed. And we can look on parking areas where we can use energy generation as a site part. And on compromised land such as landfills, open areas, brownfields, we can move on to solar panels, but we want to look on whether we can save the field without disturbing its greenery and the natural vegetations. And then we can do a conduct a solar assessment once preliminary site assessment are concluded. So it provides an estimation on system size, its production, its cost and economic overview for the relevant solar availability. So here is an example where you can move on a video clip. You can watch this and have an idea more on this topic. And next, let's move on to the second stage.